Borewell India Foundation is one of the India's leading consultancy in groundwater exploration. At first, the groundwater surveyor analyzes the topography of the area to be surveyed to understand the geomorphology. Based on the visualized rocks, the classifications of rocks are been determined to understand the geology of the coordinate to be measured. The brunt and transit is used first to understand the directional values in three different axes, which provides a sign of evidence in prospection. The transit values measured are interpreted on land, and the direction based on the sine wave values are produced high as per the magnetic curve in statics. First stage. Geomagnetic survey. Measurement of magnetism produced from natural earth. We implement the measurement of geomagnetic frequency to detect the site variations as per produced magnetic signs which changes in each location. The surveyor analyzes the highest frequency measured in x-axis followed by y-axis followed by z-axis. Once the highest frequency axis is displayed in the BH level, the surveyor follows the parallel axis from the startup zone to analyze the difference in potential until the readings are displaying a highest geomagnetic value which is produced from the Earth's natural magnetic field. The point has been marked as per the highest geomagnetic zone identified. Now the secondary axis is carefully determined in all the possible directions to classify the flow direction for the source which has been marked. When the surveyor follows the secondary axis, the highest reading indicates the directional flow. When the surveyor follows the secondary axis to find the highest value, the readings and BH values changes as per the moved direction and prospect. The sign has been generated due to the geomagnetic field produced due to the fractures and aquifers which are naturally formed due to the rainfall recharge. To estimate the depth, the measurement is taken from the identified point to the secondary axis in the flow direction indicated, which is then calculated as per the geological formulas. To estimate the depth need to be drilled to reach the fracture. Second stage. Geoelectrical analysis, also known as vertical electrical sounding. The electrical survey is one of the process in which we insert a current probe to send electrical frequencies and a potential probe to measure the drop in frequency. The probes are of minimum 1 feet in height so that when hit in the ground they at least get buried half a feet to send and receive frequencies. The probes are placed at various distances in a straight path adjacent to each other, where one probe is used to inject current and the other probe is used in measuring the potential disturbed in the frequency. By connecting transmitting cables, one to the current probe and the receiving cable to the potential probe, and needs to check the connections so that they are hard enough to produce the readings from the ground. The surveyor now turns on the geoelectrical system to take down the readings caused from the current probe and potential probe. The readings display the values for current, resistivity and permeability to calculate the thickness of fracture and to estimate depth. These readings are noted down for further calculation and reference to allot the accurate Borewell drilling point. Stage 3. Remote Sensing Geographical Information System. Generally classified as satellite survey, the GIS survey is performed to estimate the flow of water bodies into the identified points. For more details, contact Borewell taken from the identified point to the secondary axis in the flow direction indicated.